Now, the BepiColombo mission to Mercury is the European Space Agency's first experience of sending an exploratory space probe to a very hot part of our solar system, 350 degrees Celsius to be exact. Two spacecraft will be launched in 2013 and are expected to reach the planet no less than 6 years later. This important mission will be made possible in part by researchers at Tyndall National Institute in Cork. One of the researchers joins us this morning, Brendan O'Neill, along with Sean Duke of the Science Spin magazine. You're very welcome, gentlemen. Good morning. Thank you very much. This is exciting. It's great to see Ireland being involved in some aspect of the space exploration. I mean,
absolutely, yeah. This is another prestige mission of the European Space Agency, and here in Ireland we've got a research institute in Cork that's right up there making it all happen.
Well, tell us why Mercury. What's the fascination?
Well, Mercury, actually, I think there's only been two previous missions, one in the 70s and one a little bit later, to Mercury. So even though it's only the second planet over from us, we actually know very little about it. So there's obviously a big scientific interest in Mercury. It's got very strange gravity, very strong gravity. You know, so there's a lot that scientists want to know. So I guess it's a scientific mission primarily.
And two previous missions, what happened there? Was it Messenger and...
Messenger, yeah. Brendan, you might know a little bit more.
Mariner 10 was one in the 1970s, and both NASA missions. Messenger's still up there. It's actually not due to begin orbit until 2011.
And will it be able to relay information back?
Oh yeah, all of these will be relaying information back.
It's a big worry that the communications actually works. So Mercury again, then, when we look at going back in the 70s and the advance in technology from then to now, if you like, what difficulties will face the craft that's going up?
Well, the biggest issue is that it's so close to the Sun. Mercury is the closest planet to the Sun, so as you said before, the temperatures are going to be very, very high, around about 350 degrees centigrade. So particularly for the electronics that are on board, these modules still have to endure these very high temperatures, and it's very, very difficult. Typically, you know, silicon is used for most of the electronic devices. Silicon has a lot of difficulty up at those very high temperatures, and some of the newer materials that have been used, like gallium nitride, silicon carbide, they have better high temperature properties. So we're working on some of the issues that are involved in getting these materials to operate at these very high temperatures. This is fantastic.
Tell us a little bit about the research then at Tyndall.
Well, Tyndall is the largest research institute in Ireland, and we do research in all of the areas of information and communication technology, photonics, nano and microelectronics. We have a theory modelling group, microsystems. So we span all of the areas of information and communication technologies.
And what sort of information will the craft be feeding back to the base?
Well, mostly about the atmosphere. It should give us some information about, you know, the origins of our own solar system. It has some very, very unusual properties. It's quite small, but has very strong magnetic field and gravitational field. And also, they think that the core of Mercury there's quite a bit of iron in it, although they're not seeing any iron in the spectroscopic examinations that they're doing from Earth. So they need to get up close and get the orbiters in close to get better information.
And where will it launch from?
It's going to launch from French Guiana.
Okay. And will there be one craft or two?
No, there's actually two. It's a collaboration between the Japanese Space Agency and the European Space Agency. So each of them have one module. One will orbit in the magnetosphere, and the other will have a different orbit around the poles.
Excellent stuff. And what sort of finance is this going to
I think from the European Space Agency, it's round about just over 600 million. So it's one of the more expensive projects that the European Space Agency has taken on. I think somewhere around 660 million.
And it's easy to come in and criticise that and saying, you know, in the current climate, blah, blah, blah. But the breakthrough and even the materials you're developing, they could be adapted to other uses, not just necessarily for this particular space trip.
Yes, well, the computer side of things, I mean, a computer at the moment overheats if you use it too much. So the problem is the material. You know, the material it can't cope with the heat that well. So something like this could be transferred into a new material you could use in a computer, so the computer could run faster and, you know, much better. Because at the moment you'd hear a fan. If the computer is heating up, you'd hear a fan going. So that's because the material isn't working that efficiently. So this could spin off into on-Earth applications.
Absolutely brilliant. Why is it taking so long? Has there been ongoing plans, or were things just shelved? And someone decided, look, we got to revisit Mercury. We got to look back at this now. Or has there been ongoing research into going back since the 70s and 80s?
Well, I mean, the two previous ones were by NASA. I suppose the European scientists want to have their own modules with their own experiments going up there. And as I said, it's a shared mission between the Japanese Space Agency and the European Space Agency. So on the European module, there's something like 11 different experiments on that module, you know, each with a principal investigator looking after the particular experiment. So, you know, all of these scientists want to find out different things about what's going on within the atmosphere, about, you know, the gravitational fields, the magnetic fields, all of those issues. So they're all putting on their own experiments on the module.
And would it be extremely competitive between NASA and the European Space Agency, or is there a heck of a lot of cooperation and sharing of files and things?
There's more cooperation these days, I think, on a lot of missions, because they're so expensive. I mean, even the Americans are struggling to fund their space program. And that's, for example, why you don't see a lot of manned missions anymore, because they're so expensive. So, you know, the days of the Russians and the Americans competing, I think it's a different scene now, would you say, Brandon?
Yeah, there seems to be a lot of collaboration. I think even the rocket that's going to put them up there is a Soyuz rocket.
Yeah, the Russians traditionally had these very powerful rockets, you know, so we all need to use those.
And how will the staff at Tyndall, how many staff? Tell us a little bit about the research
there's
facility.
about 500 people working at Tyndall. It's a very, very large research institute, and about 100 of those are PhD students, and all of the rest would be staff. I suppose about 50 support staff. All the rest would be engineers, technicians, and mainly research scientists.
So counting down the day to launch and looking forward to it, no doubt.
Yeah, particularly the guys involved in the particular project will be looking forward to getting their parts up in space. Fantastic.
Well, look, thanks for coming in and sharing that story with us. Interesting, informative. And Sean, as usual, thank you very much for finding some great guests.
Okay, thanks, Aidan.
Thanks.